The backdating feature found in Reduxio storage arrays boasts the ability to restore data volumes to any point in time, right to the second. In this video, we compare backdating to snapshot technology, which is widely used by legacy storage systems. Let's begin by setting up a hypothetical snapshot schedule on our array, which typically requires doing all of the following: designating a reserve volume to contain the snapshots, creating a schedule to set the frequency that snapshots occur, specify how much of our free space we want to designate to snapshots, setting a warning level to alert us when free space is running low, set up a contingency plan should the snapshot reserve get filled up. This could include deleting the oldest snapshots or taking the reserve volume offline. Both are potentially dangerous options if left unadministered. Now let's configure the backdating feature on our Reduxio array. Actually, there is nothing to configure. The Reduxio array has a default retention policy that provides 8 hours of to-the-second data restoration right out of the box. If you want more, you can change the default policy and expand your to-the-second coverage for multiple days or weeks. Backdating requires little in terms of raw storage because, unlike snapshots, backdating only stores metadata about the state of the storage and not the physical storage block. Beyond the 1-second window, older data is still fully recoverable in gradually expanding intervals. So, what is backdating? Backdating is a new technology implemented in all Reduxio storage systems that allows you to recover data on a second-by-second basis instead of from discretely scheduled snapshots. Backdating was designed to solve the many shortcomings of snapshot technology, such as data loss resulting from too few recovery points, the time required to administer and manage collections of snapshot data, and the hours it takes to restore multiple database or application volumes from snapshots. If you are knowledgeable about storage, you may be thinking, that is impossible. Or you may be thinking that backdating must be a glorified snapshot technology that consumes huge amounts of available storage. But that would miss the point completely. Backdating is a completely new innovation in the way data changes are tracked, retained, and restored. Let us take a moment to revisit snapshots so we can understand where these problems originate from. Snapshots record the changes that occur in a volume between adjacent snap intervals, which makes them more space efficient than full backups and accounts for their popularity in most legacy storage systems. We can also see that any incremental file changes made in between snapshots would not be preserved. This leads to the great trade-off that plagues snapshots. Taking frequent snapshots consumes more storage space but provides more restore points and lower RTO. Taking fewer snapshots conserves storage but results in fewer restore points and higher RTO. When snapshot frequency and risk are balanced optimally, snapshots typically consume 25 to 50% of the total storage. Left unmanaged, snapshots would continue to grow in number and occupy more and more free storage space, which is one reason they require regular administration. And when the inevitable disaster happens and volumes need to be restored, snapshots don't always make it easy, particularly in environments where database applications access multiple volumes simultaneously. Since each volume has its own collection of snapshots, these need to be carefully synchronized for consistency to avoid data loss. This process typically takes hours, adding to the overall RTO. There was a time when all of these problems that come with snapshots were considered reasonable, compared to the alternative, which was a cumbersome full data backup taken at the end of each day. Learn the basics of upgrading your storage solution. Visit us at www.coreevolutiongroup.com to download our new ebook.